Okay, we're going to work through this example together. This looks at just how big the distances are in space and the sort of time it would take us to travel even to our nearest star. So when we're measuring distances in space, they're so big that using even a meter or a kilometer just becomes meaningless. So instead, what we use is this term called a light year. A light year is not a measure of time. It's a key thing. It is a measure of distance, and it is how far light would travel, which is the fastest thing in the entire universe, in 1 Earth year. Okay. Now that makes it quite a big distance. So let's look at the nearest star to our sun is Proxima Centauri, and this is about 4.2 light years away. And the question asks, how long does it take light from Proxima Centauri to reach Earth? And by definition, if it's 4.2 light years away, it takes 4.2 years for the light to reach us from Proxima Centauri. So how far is it from Earth to Proxima Centauri in kilometers? So we know that the time taken for that light to reach us is 4.2 years, but if we multiply that by 365, that would give us it in days, multiply by 24 hours, multiply by 60 minutes, and multiply by 60, it will give us it in seconds. So if we do that on the calculator, 365 times 24 times 60 times 60, and that gives us 1.32 by 10 to the 8 seconds. Okay, I've got such big numbers here, we're going to be using standard form. The speed that light travels at is 300 million meters every single second, or we can just write that as 3 by 10 to the 8 meters per second, which means then if we do our speed equals distance divided by time, and we put in our values, 3 by 10 to the 8 equals the distance divided by 1.32 by 10 to the 8, multiply that out, and it gives us 3.97 by 10 to the 16 meters, because this was meters per second. To convert that into kilometers, then we divide by 1000, which will just give us 3 less 10s really at the end of that. So the distance is 3.97 by 10 to the 13 meters. It then says space rockets, our current ones, can travel at a maximum speed of about 20,000 meters per second. Now that's really fast. I mean, that's 20 kilometers each second, which means it would take you 5 seconds to get from like Belfast to Dublin. However, if we use the distance from above, 3.97 by 10 to the 13 meters, we can do a speed equals distance divided by time calculation for a rocket to travel the same distance. Gives us a time of 1.987, let's call it, by 10 to the 12 seconds. If we then divide that by 365 multiplied by 24 multiplied by 60 multiplied by 60, so divided by all of that, that will give us 63,000 years. So if we wanted to set off in a rocket to reach our nearest star to check and see if there's any planets around it which might harbour life, it's going to take us 63,000 years to get there. And then it would take us 63,000 years to get back. We'd probably want to stay a little while there as well. It just means with conventional technology, we can't even get to our nearest star. Never mind the ones that are a little bit more distant, might be more likely to have life around them. If you then start talking about trying to get to other galaxies, the distance becomes so big, it's absolutely impossible. So it's unlikely we'll be able to travel there, which is why we rely on things like radio telescopes to try and detect signals from those other planets. What we'll do is now is I'll fill in the answers. Well, you try the questions that follow on from this. I'll fill in the answers in OneNote, and you can come back once you've done that and check your answers, and that's us done.